All right, so next thing we're going to do is the Twitter Shiny. So just like the other GitHub accounts, you're going to want to download this and through the link. And what this is going to do is create a copy, like what we call a clone of the repo. And then from that repo clone, we can download and synchronize our code together. So I'll go through it, but I probably won't be making commits as often as you should, right? Okay, so once you accept the assignment, you should get this kind of symbol that says that you have a repo called Twitter Shiny, and it's available in our classroom. So you're going to accept that, and again, this is going to take a second to configure, and then if you refresh the page, you should be able to get the link. And this will take you right to the GitHub. And right away, going through this, we're going to see a couple things. So first off is the README file pops up, and this has all the instructions for what to do to accomplish the assignment. And so we're going to go through that step by step. Again, some of this stuff might seem kind of foreign. That's because you'll be learning about Shiny in the LinkedIn videos. So hopefully you've got a chance to at least watch maybe the first chapter. But I'll kind of be talking through things here. So for a full explanation of like what are all these features doing, I will refer you to that. There's also this 2.5-hour tutorial for how to develop Shiny apps, which is very comprehensive, but maybe a little bit too much for this course. Okay, so just like before, we're going to kind of work in Rstudio, and again, you'll want to pull down the code using this HTTPS. So if you copy that URL, you should be able to go into Rstudio, create a new project, go to version control, and hopefully you don't get this error, which is that Git wasn't detected, and you have Git on your computer, and then that's where you would paste the repo, and then once you have that, it's going to pull down everything onto your computer. All those files that you can see on the website on GitHub will appear in their file folder. So make sure you're saving it in a consistent place, right? You made a directory within your kind of classroom directory, your workspace, and you're storing all the things there. Okay? So now that we have the Shiny, we want to make this a Shiny document. So the project will be pulled. Hopefully you have an environment kind of like this. So yeah, so hopefully this is what yours looks like. You have two objects in your data. One's called tweets, one's called user timeline. And you have your README files and the R data here. All right, so what we can do now is we want to create a new file, and this is where we make the R Markdown. So I'm going to go to New File, and the third one down is R Markdown. And when I select that, we've done this before where it gave us a document that had the YAML, had code chunks, and it had plain text. What we want to do now is use this portal to create a Shiny document from that. And if it's their first time running it on this computer, it's going to download a bunch of packages too. So once you have the Shiny running, and I'll come back to that once it's done running, you can name this twitter-shiny.rmd, and then you'll want to make sure it's saved in the same folder as your other documents, and it should pop up down in that lower right corner as you save it. And what you'll notice is there's, instead of having a knit button, you're going to have a green button, a little arrow that looks like a green triangle, and it's going to say run. And when you run that, what it's going to do is it's going to turn your computer into a server and start serving all the information around Shiny, which means it's ready to take user input and give back an output. And that's a lot of what these objects are, is they're reactive. They're going to depend on what the user is doing in order to give the information back to you as an output. All right? So this is the point where you can kind of see what's going on with the interactive document. So hopefully I have this ready. Yep, Twitter-Shiny. I'm going to add my name, Caleb, over here. And I'm going to select Shiny. So we'll do Shiny document. Say OK. And then here is the kind of sample Shiny. And notice already it's recognizing, hey, this package requires Shiny, but it's not installed. So I'm going to install it. One of the nice things about this feature is it helps to recognize what's going on. And as that's going, I'm also going to save this file. So I'm going to save as, and this is the same folder. I'm just going to call this Twitter-Shiny. And it should save it as a .rmd down there. Okay, so hopefully it's done loading. And then when I hit run document, what's going to do is it's going to create an interactive web page. Now, you'll notice that there's this code here that represents your computer. So it's not going to be like a normal URL that you could go share with somebody. This is something that is going to be internal to your device, so it's not hooked up to the web yet. All right. But what's nice about this is you get these inputs and outputs, right? So it gives you drop-down menus. And you can change the number of bins, and notice that the graph updates instantly. You can also change the bandwidth, so we can see distributions and change the kind of precision and clarity to those. So these are the first kind of things that you're going to learn as you create interactive dashboards, is how do I get these buttons to give different outputs. And really what you're trying to do is show the user the information that they're requesting, right? So for instance, if I have a normal distribution, I can play with the number of observations to see how that might change. And you can even create these kind of run different models to show people what the other outputs would look like. So this is great. This is kind of the application that we're looking for. And what's nice about this is that these things like adjust pretty well to different sizes. So for instance, if I make this window smaller, it's already correcting for the thinner display. So I'm going to close out of that and stop running this. All right, so let's go back to the instructions. So for this assignment, we have a couple things that we're going to want to load. Oh yeah, at this point is a good time to do a commit message. So if you've saved the document, you've run it for the first time, now would be a good time to say, creating the RMD for Shiny. And then commit that message and push it. So I won't be able to do it on mine because it's not hooked up to Git, but you should be able to do it on yours. There's probably a tab right here that says Git, G-I-T. Okay. So the next step, we want to load Twitter data. Now, there's a lot of different ways that we can do this. Some people might just go to the website and copy and paste the tweets and put them in a spreadsheet, but that's going to be pretty labor intensive, and it's not going to be up to date, right? If another day goes by, there's going to be more tweets out there. So instead, there are these packages that help us connect to Twitter servers, and we can get the information directly from the source, the database that's hosting all of these. So what I'm going to do is use this setup chunk and download a bunch of the packages that I need to run the Shiny thing. So the first one is R Tweets. This is a package made for R to interface with Twitter. And then of course we have Tidyverse, I'm not sure how to say this one. Then we also have Emo and Word Cloud. So these ones will be useful for some of the data visualizations we want to make. There's also DT, which helps us display data tables in an interactive way, and Tidy Text, which is the tidyverse version of how to work with text. So I'm going to have, let's see, rather than writing this all out, I'm just going to copy this part. Again, for the purposes of learning, it's good to include typing all of this out, but there's a lot of libraries here, and I think we've already gone over that in the past, so I'm not going to take time to do that now. Okay, so now I have my setup chunk. I'm just pasting it back into here, and actually I'm going to kind of remove these other parts for now, and you'll see why in a sec. Okay, so I'm going to go ahead and save this. And notice that when I saved it, now it's updated. It says, hey, these packages are required but not installed. And I'm going to hit install packages. And if I were to look at what's happening to the console, it's going to do the install packages command for each of the ones that were listed that we're missing. And it's going to pull down more information from the CRAN and from GitHub if needed. So hopefully you've been able to commit your changes up to this point, and your R console is talking to GitHub and sending the changes you're making to the code back to GitHub. Right? And remember, the reason why we use that is because it helps us control versions, it also helps us collaborate, and it gets acknowledgement that you contributed that section of code each time you're pushing your changes. All right? And until you push, nothing is shared. It's all on your device. So you could have made all the commits along the way and have a whole timeline, but it won't be showing up there until you've linked both sets. Okay, so, and if you're having trouble committing, kind of like I'm doing, you can probably still work along, but you'll want to redo this when you have time to add the commits. Okay, so the next thing is we're going to go through what we call the introduction. So underneath the setup chunk, replace the text with the following header and text. So remember that when we have a double hashtag, it doesn't mean that we don't read the line, it means that this represents a header, just like you would see here, this being its own section. And then we're going to say this R Markdown document is made interactive using Shiny to demonstrate my ability to make an interactive data visualization, or interactive data visualizations. Okay. So I'm going to go ahead and add that to my R. So here I'm going to add double hashtag introduction, and this R Markdown document shows how I can use Shiny to make interactive data visualizations. Okay, so we're going to save this, and again, you want to commit your changes. You can say something like adding an introductory text, and then you're going to want to stage those changes, hit the commit button, and push it. So that's that section, and now we're ready for the next one, which is the load the data chunk. You're going to create a new data chunk, and we're going to call this the load data chunk, following this kind of demarcation here. So I'm going to create some new lines, add a few 3 backticks to represent that this is going to be a coded chunk where the coding language is, and then I'm going to do R load data, then I'll do comma include equals false. So I'm doing include false so that when we go to render this website, it's not going to show the code and the outputs, right? It's just going to be running in the background, really. Okay, and then I'm going to close out the backticks a few lines later, so now I have a closed chunk, And then inside this closed chunk is where I'm going to start adding this extra information. So the data set that I have loaded in here, it comes from the Our Lady Shiny, which is a rotating Twitter account shared with the Our Ladies group from Seattle. And so if you want to use that, you can. If you instead maybe want to download your own tweets, or maybe find tweets specific to a topic, I don't know, maybe you're following like the Marvel movies or something like that, you could look for #Marvel. So in this case, I'll show you the first version. So we would do load and then quote data.ourData end quote. So I'll show you how to do that. So we go load. Again, load is a function, and you can see it's already coming up as I type this out. And then parentheses, and then the file name is data.ourData. And there's capital R, capital D. And you'll notice that that is a file in this directory, right? That's something that was brought in when you downloaded the data, or when you downloaded the Git package. That repo brought along a bunch of other stuff, including this R data package. So this is one that I had saved earlier, and it's back here for your use. So if I run this, object not found. Oh, I forgot one important thing. You got to put this in quotes because this is the name of the file. So I'm going to use single quotes to denote that I want you to load a file named data.ourData. And you'll notice when I did that, some more information popped up here. User timeline, user status. And I think maybe the tweets got updated too. All right, so that's the easy way, and that's all that's needed for this assignment. If instead you want to use separate data, you can also do this. Bring in those tweets from a separate thing, and what will happen is as you run that code, it will ask you to authorize our tweets to access your Twitter account, and then you have to put in your Twitter credentials, and that'll allow you to use your Twitter account to pool data. Pretty cool. So I'll show you with 9. Okay, so again, for this next part, you don't have to do this if you're satisfied with just using the data that's provided. So I'm going to just copy and paste that there. Again, get in the habit of writing things out, but in the interest of time, I want to do this quickly. Okay, so already it says can't find this function, get timeline. So let's see. Sometimes these codes change. Okay, so yeah, it looks like this is the right one. So I'm going to try library R tweets to see if that worked. Just having a hard time searching. Okay, yeah, so I got this window. It says, would you like to authorize your account? And here I can add my username, and I don't even know what my password is anymore. It's like, you know, one of the first security things I learned was you gotta use different passwords on different websites, right? Yeah. But the consequence of that is now you can't remember any of them. I wonder if this will even work. Okay, yeah, so, and then I got this other menu. It says authentication complete. Please close this page and return to R. Okay, so now when I run this, it's going to give me a new set of tweets, and it's going to take a little while to download. But what did I ask for? So you can look at the specific arguments, but basically what it's pulling from me is tweets, the last 16,000 tweets that have R stats as a hashtag in them. Right, so that's a lot of tweets. And you could do this with any, you know, replace R stats with whatever you want. You could do Marvel here, you could do anything like that. So as that happens, this will probably get updated. And if you look at the this second line that says user timeline, get timeline. Now again, this is already loaded, but this one will be the more recent one, and this will pull from the account, Our Lady Seattle, the most recent statuses that they've had. And the N represents up to 900. So I can see what their last 900 tweets were. All right. And if I click on that data object, I can kind of go through and see what those look like. So, yeah, this is most recent tweet was on the 12th of this year, of last month, I guess. So, again, we have the, you can look at the data that's stored by clicking on this panel here, and you'll notice that there are lots of different objects stored here. So the user timeline was the one I just pulled. And again, each one of these rows is an observation, right? It represents a tweet that was submitted by that user. And then each column represents a variable that was stored associated with that tweet. So this is a rectangular data set. I have my observations and I have my variables. And you can see that some of these are simple things like, things that keep track of what ID it was. And then like timestamps. Then I have the actual text there. I can see whether they were on a phone or the web app, how many texts there were. And then I can also count things like, was this retweeted? Was this favorited? All of that data is stored in this. So this is like what happens behind the scenes when you have all these programs running. They have this really smooth interface, and you're like, oh, I can just endlessly scroll. All of that is running through computer systems that rely on data that's storing things in a reliable way. And right now what we've done is use R to talk to R back to Twitter and get the data that we need from that. So very good use of gathering data. Okay, but for this part, like I said, you can do just load data.rdata if you don't have any of that. And I'll save it so it looks like your version if this is what you're doing. Okay, so going back to the instructions, so we were able to successfully load the tweets. We can see those in that upper panel. That's a stored object now, and it has information for us. So we're going to, again, write a commit message, stage your commits, hit the commit button, push your changes, make sure that they go through to your main branch. Okay, so the next thing I want to show you is how to create two tabs for organizing the data. So the nice thing about Shiny is it's really meant to be a web portal. So whereas when we're working in R Markdown, oftentimes you're kind of working with like physical documents, like things like PDFs, things that people print. With the web format, it's going to be more how people interact. So we can use what's called a tab set to create menus and different windows like tabs. So we're going to do the same thing here. I'm going to add a header and a subheader, and I'm going to look through it like that. So let's do double hashtag, and then I'm going to say Twitter data. Then I'm going to use these curly brackets .tab set to represent that this is a tab. Just like in the instructions. All right, and then I'm going to do two spaces. So one thing you'll notice is usually after these headers, you want to add an extra blank line between your text and the next header. And I'm going to add the other two here. So now I have a 3 hashtag header, This means it's a subheader. It's subordinate to that top one. And this will give me what the tabs actually are. So this one says recent R stats tweets. Again, if you wanted to change this to Marvel tweets, you could do Marvel. I don't know why I'm thinking about Marvel today, but recent R stats tweets. And then I'm going to do another line, and then a new line after that to do tweets from @Our Lady Seattle. All right. So this is kind of like the framework. Again, the nice thing about R Markdown is it allows you to blend code and text that a human would read. So now we have this kind of structure built in, and when we run, let's see. Yeah, well, we're not ready to run it yet, but basically what this will look like is, yeah, might as well. What this will look like is kind of a really basic web page that has just like a couple buttons and tabs. It doesn't like that one. So I ran into this problem last year too. So some computers don't like the emo package. What that one's really useful for is creating emotes and showing emotes. But we might have to pull that from GitHub rather than the CRAN. Okay, so yeah, this is kind of like the basic outline now, right? So my hashtags, they became the headers, and then those subordinate ones, because we called it a tab set, now I have two tabs that I can click on and navigate that way. So this wouldn't be hard to do with, basic web design, HTML containers, but our Shiny made it really easy. So now is where we get to do the fun stuff, which is create the interactions. So what you'll notice you'll be working with is what's called an input panel. And this is just like what we saw earlier. This is where the user can do drop downs, can type things, can push all kinds of buttons. So we're going to put this in the first one. So think about those tabs as different sections now. We're going to have one section for this, and then we'll look at the other section in a minute. So we're going to add some text there. It says the plot below shows time series of R stats tweets and can be filtered by language. Okay, so I'm going to add some plain text. Again, we're going to be in this section here, so don't do it at the very end. I'm going to create a few spaces after recent R tweets. So this section will display, what did it say? Oh, here. Actually, sorry, this should say the plot below shows time series of our stats tweets. Plot displays time of hashtag R stats and can be filtered by language. Okay, so already we're kind of starting to set the stage for what we want this to show. We want to be a time series, and we want it to be filterable by language. Right, so we can already think about what's that output going to look like, and what kind of input do we want from the user. Well, we probably want the user to tell us what language they want us to show, right? So, filtered. Okay. Also, stats is a palindrome. I don't know if you knew that. Okay, so here we go. Next thing we're going to do is this part here. Create a new chunk titled R tweets. And then with the echo equals false, what that means is it's not going to print out extra information as we continue to get outputs. But it will show the actual panel. Okay, so what we're going to do is we're going to add components to the Shiny app. This chunk will give us that input panel. And this is where we're going to ask the user to choose what language. So I'm going to go ahead and write the chunks first. So again, I've got to do 3 backticks. It's the button right next to the number 1. Let's say R tweets, comma, echo equals false. And then I'm going to close those backticks down below just so I make sure I have my borders to my chunk. And then within this is where I'm going to start writing my first command, input panel. So this is a function, and if I go to help, I can see what this function does. So input panel. And it says there's a help page, and it's for the Shiny package input panel. That looks about right. And it says a flow layout with gray border and light gray background suitable for wrapping inputs. Oh, perfect. That's just what we need. Input panel. So a lot of what we're going to be working with are kind of like thinking about things in modular units, like stuff that fits within stuff, right? So like these headers that we built, they're going to be the containers that we put our inputs in and put our outputs in. So you can think about this as kind of like creating boxes, and then within the boxes there are different parts that work within them. So this is our big box for the inputs. And then within this input, we're going to have another box, which I will call select input. So when you're working with Shiny, there's a lot of different ways you can work with inputs, right? Sometimes you might have a slider. Sometimes it might be there are 3 options, you have to choose one. Well, what if there are 3 options and you want to choose all of them? You can specify all of that. So what we're going to be doing here is working with the select input data and use this to specify the language of the tweets. And of course we have to link it to the data because we don't want to just have every single language listed. Maybe we only want the languages that are actually in the data set, right? Okay, so I'm going to use this select input. And again, I can look up what that does, select input. So here's the Shiny select input, create a list of select. Create a select list that can be used to choose a single or multiple items from a list of values. That sounds about right. So the first thing that it's going to do is your input ID. So this is what you want to call whatever the variable is that the user selects. So another way of saying that is like, what are we going to name the information that we get from the user? So in this case, I'm going to call this tweet lang. And that way that we can refer back to it later and say, oh, this is the language that the user selected. We're going to use that as our kind of variable to use the inputs for rendering our graph. So let's go ahead and do that. So I'm going to put, just like this one says, a tweet lang, comma, label. So there's also a way that we can add the labels too. So tweet lang, that's short for tweet language. Usually you want to name your objects things that make sense and are identifiable and unique so that they're not like, object 1, object 2, object 3. It quickly gets hard to keep track of things. And then the label is pretty much like what do you want the button to say on it. So you might say, in this case we're going to say language of tweets. So sometimes people put like instructions for the user, like select the one you agree with most. You could put that there, right? Okay. And then, so those were the first 2 arguments, and then we can do comma, and then how are we going to have choices for the user? Oh, I realize this is probably still on. And so you have to specify which choices the user is going to give. And to do that, we can actually use the list that's already provided to us. And so if I say choices equal unique, unique tweets, and then money sign Lang. Okay, so what did I do here? So this is, again, kind of a series of steps. So we know that there's an object called tweets. That's where the data is stored. And then that money sign means there's a column inside that tweet object that has a list of all the languages. So go find all your Twitter data, gather the list of every language that the tweets are in, and then what we're going to do is reduce this to just the unique ones. So if English shows up more than once, we're just going to count it once. Does that make sense? So the argument for choices is going to say, okay, to figure out how many choices we have, try and find the unique number of languages in our data set. And luckily there's a column that keeps track of that, otherwise it would be pretty hard. And then you can also kind of select the default, so the selected default will be English. So I'm going to say selected equals quote EN to represent English. And then there's one last argument here, and it's multiple equals true. So that means that if somebody wants to choose more than one language, they can. So you would make this false if you wanted only one language at a time. Okay, so that should be our input panel. Okay, so there we go. So this is our input panel, and now you can see there's a list of languages for the tweets, and I can choose from that drop-down menu any of these languages. And multiple of them too, which is pretty cool. We're going to keep moving on. So hopefully you've committed all of these, and you can run the document and see that there are abbreviations available. So next thing we want to do is renderPlot. So as I was saying, a lot of what we do with interactive data visualizations is depend on the user, give us some input, and then we'll give them back the information they want. So the next part is going to be focusing on rendering a plot, basically making a graph using the information that was given to us. All right, so for this one, we're going to use this command called renderPlot, and you'll notice it looks a little different than the input panel. It's different because we now have this extra curly bracket in here, and what that means is this is going to be interactive in the sense of like it's going to update as the input panel changes. So to render the plot, again, let's look at the code. So the first thing is ts_plot. This is like a ggplot in the sense that it's a time series plot. It's just kind of a shortcut to build them. So a time series plot of tweets, and those tweets are going to be filtered by language that is in the list of tweet languages that the user selected. So having this kind of input here means that we have a list that we can use from the user in order to filter our tweets that we're going to plot. And then we can plot these by hour and use the color blue to show them. And then I also have some extra commands here. This adds or removes the X and Y label, and then adds a title and a subtitle, as well as some captions. So let's try this out. So again, we're going to do renderPlot. We're going to work in the same chunk that we had before for the tweets. Oh wait, wrong one. Here we go. So input panel, a couple new lines. Again, I'm still in this kind of shaded area. renderPlot, and then normal parentheses, then curly parentheses or curly bracket, and then a TS underscore plot, and then what we have here is the data, and the data is going to have some piping. So the data are tweets, and the piping is going to allow me to filter these. Filter, and again, filter is its own function. Filter lang is in. I'm going to use this in function because it can be any of the languages in the list. In input money sign tweet lang. Remember, that's the object that we made based upon whatever the user gave us. Okay, and then let me look back at the notes here. So we have filter lang in input tweet lang, and then a comma. I'm going to do by hours, comma, colored blue. Oh, shoot. By hours, comma, col equal blue. Okay, so even without the extra stuff, I think this will probably run. Let me see. Might not look great. Yeah, so already we got our first plot. And it has some time frames. It shows the number here. And what we're going to do is make this a little cleaner and look better. But hopefully this is already adaptive, so if I want to add French, and I don't know what this is, Denmark. And then I can get rid of English. So it updates in real time, which is pretty cool. And maybe I want to add some more. So you're already on your path to creating an interactive data visual. Pretty cool, huh? In addition to the plot, though, I'm going to add some extra information, so I'm going to create a few more lines down here. So the first thing is I want to get rid of those labels because they look really clunky. Here, I'll run it again so you can see what it looks like. So, you know, obviously, whenever you're working with graphs, it's going to make a lot of assumptions about what you want and where you want it. And the nice thing about R is you can tell it exactly what you want. So, for instance, right here it has this little number n. That's just the number of tweets given at that particular time. So if I don't want an n to show up on that plot, I can just tell R to get rid of it. Same thing with this time. Like, if it's intuitive that these are dates, then I shouldn't have to specify that it's time. Less is more in this sense. So this is where you start to shift between, you know, in elementary school, middle school, high school, you're probably taught, make sure everything has an X label for your X axes, make sure all your Y labels are labeled. Well, that's true, but if it's intuitive and you don't have to explain it, or the title does the work for you, you can, you know, think about how to simplify your design. Okay, so we'll go ahead and add these. So we'll do labels equal null. Okay, so I'm keeping an eye on the clock. So for the interest of time, I'm going to copy these in just so we can keep moving and I don't bore you to death. But yeah, please get in the habit of writing this out. Okay, so what that did, it adds labels, adds a title, adds a subtitle. The interesting thing about the subtitle is it's going to tell you, it's going to combine information from the data. So what this says is find the earliest tweet by date, and that will become the part of the subtitle, and then it'll also say what the latest date was. So we have some descriptive subtitle that's going to update based upon what the figure says. So, which is pretty cool when you think about it. It means that you can integrate text that's going to adapt as the user changes their inputs. Okay, so this looks pretty good. Let's run it. So this theme minimal is one of my favorites. What it does is it takes away that gray background and makes a really crisp white one with a simple grid. And so here we go. Now we have a new plot, and this will update as I add more information. So pretty cool. So, good work so far. So what you want to do now is go ahead and commit, save that. The next thing we want to do is add a data table. And to do that, we're going to use a very similar method. Instead of doing renderPlot, which is going to take those inputs and update them in real time, we're going to do renderDataTable. And what this will do is create a table for us that plots the tweets that we want to select. So for instance, again, here's the code. So we'll go ahead and add that back here. Here, I'm going to stop running that for a bit. So I'm going to work in the same chunk. The nice thing about that is it's going to keep everything organized in one place. So render data table. This comes from the DT package that we had downloaded earlier. And again, I'm going to use those curly brackets. That's one thing that's unique about Shiny. It really depends on those. And then within this, I'm going to use this tweets. Same thing, filter it by, I'm going to use piping to my tweets objects, and I'm going to filter it by language. So lang is, the language has to be something within the list that the user selected. So lang %in %, input $, tweet lang. And the next one is I'm going to do a select column. So the reason why I want to do a select thing is because this is 90 variables in here. So even if I just pulled the tweets that match the language I'm interested in, it's going to create 90 columns, which is way more than the user needs. So let's focus on just the tweets that the columns that have the most interesting information. And in this case, it's going to be who said it, what did they say, what language was it in, how many people liked it, and how many people retweeted it. So let's go ahead and use this for the select. And that's nice because it gets us down to 5 columns instead of 90. And again, for the sake of time, I'm going to copy and paste, but please get in the habit of writing things out because it helps you think about how the code works. If you say, oh, screen name is a column in the tweets data set, and it should be there even after I filter the language. Okay, so here's a good time to save and commit, and I'm going to go ahead and run this and see if we get a data table. Please work. So one thing you'll notice is that as you start building these bigger and bigger, it takes longer and longer for them to load. All right, and it looks like we got it. So I can now, let's say I want to search for Spanish. I can now see all of the tweets in Spanish for our that have the hashtag #RStats. So what's nice about this is already it has a bunch of extra interactive features. So I can sort my tweets. I can find the most favorited ones. I can even search by text. So maybe I want to see, is anybody talking about tidyverse in this? And it looks like it occurs at least once. So this is kind of the way that you've now integrated a user input to a data visualization and a data table, right? And if you're thinking about this for your project, you can be like, well, if I want to look at unemployment rates around the US, maybe it would be good to have a place where somebody can specify what city or county they're interested in. And then once they tell me that, it'll update the map and show them what the unemployment rates look like in that area. So this is the kind of reactivity that we like to see as we're building these things. Okay, so let's go back here. Go ahead and commit and save that. For the next one, we're going to work with the Our Ladies. So we've focused on tweets. Now let's look at a particular user and see if we can show those for this particular user. So the plot below shows top emojis used, a Wordle of terms, and a time series of tweets by Our Ladies Seattle. The time series can be plotted with different sources to see when different devices were used to tweet. Okay, so there's a lot to unpack here. But again, we're going to kind of scroll down, and underneath this second header, the tweets for Our Ladies, we can say what we're going to do. So below includes, I've already forgotten, the top emojis used, a list of the top, you call them emojis or emotes? Emojis used by Our Ladies Seattle, as well as a Wordle. Wordles are like word clouds. And a time series of tweets showing different devices used. Okay, that's close enough. Next thing is, so now we have another subheader. This one has got 4 hashtags, which means it's going to be even more subordinate than the one that we're on right now. So I'm going to include that here. Oh, here, I made some misspellings. Okay, it says it wants emotes. 1, 2, 3, 4 time series. So time series plot. All right, so for this one, I'm going to have another interface. This is for input from the user. And what I want to call this one is tweet source. So maybe I want to see when did somebody change devices, right? Like this is supposed to be a count that rotates. So I'd expect maybe some people have Apple phones, some people have Windows phones, some people are probably using a web browser to use Twitter. So maybe I could see like when people change devices, does that mark like when the account has changed hands? So for this one, I'm going to do our user as with 3 backticks. I'm going to make a chunk called our user. Then I'm also going to do echo equals false. And then I'm going to close my chunk just so I get in the habit of making sure that it's all shaded first. Our input panel. And again, I'm going to add some quotes. And then the next line I have select input. So I have to specify that I want this to be the place where I gather information from the user. And here we can call this tweet, what did I call it? Tweet source. So I can see what kind of device was used to make the tweets. And then let's look at, we'll call this a label. So label equals, quote, source of tweets. Again, this simply tells the user what they're selecting from that list. And then the choices are going to be, just like before, we're going to focus on the data. This time it's the user timeline. So a new line, user timeline. Oh wait, I messed that up already. Choices equal unique. So just like before, let the user pick from the data that we want, and we can select the variable that we want them to choose. And in this case, it is the data sets from the user timeline, which was different than the tweets that were based around the topic. And here, I'm just going to type out source. There it is. So the source will tell us where the tweets came from, and we can have the default of selecting everything. So we just do the same thing. We say comma selected equals unique. So what that will do is, by default, everything that's on there will show up in the graph, and then if the user wants to remove a particular source, they can. And I think there's one other argument. Oh yeah, multiple equals true. Okay, that should do it. So this again is a new input panel, and it's going to show up on that other tab, and what it will do is ask the user what source of tweets they want to select and store it as an object in the input data called tweet source. So here's my first page. Again, this has everything that we built already, an updating dashboard and graph. And if I go to this other one, now I can see there's some different options here for the source of the tweets. But there's no graph here, which is not surprising because we haven't written any of that render plot or anything like that yet. Okay. So don't forget to write a commit message and save it. Okay, so just like before, we're going to do the same thing. We're going to create a plot based around the data that the user selected. So we're going to do renderPlot and input that here. So renderPlot. Again, this one's going to have the curly brackets because it's reactive to whatever the input was. And I'm going to do a tsplot. Okay. And again, for the sake of time, I'm just going to copy and paste this. This says a lot of the same things that we did earlier. But I want to be able to finish before the hour's up. Okay. So what this will do is take the timeline, filter it by the sources that were selected by the user. Again, all of them were selected by default. Instead of hour by hour, this is going to be at the level of months. And we also have a title which we're going to call Frequency of Tweets from Our Lady Seattle. And we're going to make a subtitle that updates based upon what the user selects. And we have a caption here, data collected from Twitter's REST API via our tweet. And then the theme here is minimal, so we don't have that gray background. It's all white. So let's run this and see if it works. And there we go. So our second window is there. We can see there's kind of rise and fall in the tweets throughout the last year. And maybe I want to get rid of the Androids and just see, what people are doing on their iPhones. Okay, so it looks like, yeah, nobody's been on the iPhone and tweeting for quite a while. That dropped off pretty quickly. Again, your data set might look different because if you're using the stored data, it's probably all pushed back to last year, the last time I updated the data. Okay. So we're building interactive web platform. Now we have one other thing we can add, which is this renderDataTable. And what this will do is just show what were some of the texts that this person had, and how many times were they retweeted, how many times were they favorited. And we can add this extra command here called arrange in descending order by retweet count. So what that will do is say, oh, this one got retweeted the most, that's going to be our top line of the table, and then we'll go down from there, which is kind of a nice way to showcase like what were the most contributing things. So again, I'm going to copy and paste for the sake of time, but you should practice writing all of this out. So renderDataTable is going to be the next output, and I'm going to run the document. And as it's loading, again, this would be a good time to write your commit messages and save the documents. All right, so it looks like my data table is showing up for the other one now, and I can see the most retweeted one was actually this one here, which has 711 retweets. All right, so for this next one, what are we going to do is take all those emotes and see, okay, what were some of the top emotes that this user used? Oftentimes when you're working with like text data, programs will kind of strip away all the extra information, and so you'll just get the words. But maybe you actually care about, what kind of emotes they were using as they were writing about these tweets. And so this next section is all about using those emotes to show what people are using, what their top emotes are. So I'm going to do that here. I'm going to do 4 hashtags, and I'm going to call this top emotes or top emojis. And I'm going to do the same thing. I'm going to do a renderTable inside this new R chunk. So I'm going to do 3 backticks, R, and I'll call this emotes, and then echo equals false. And inside this, I got 3 backticks. So now what I want to do is render data table, and the data I want to work with for this are the user timeline. So again, we're going to be working with the R Lady Seattle, and then I'm going to add some piping, and of course I want to do what's called mutate GI extract all text. So what this does is it's going to pull all of the emotes out of the text. And if this part doesn't work, that's okay. It might. I remember last year some students were able to get this to work and others were not. So and it seemed to vary highly on what kind of computer they had. So again, I'm just going to copy and paste for the sake of time, but basically these other commands will filter it. Or I'm going to fix the alignment here just so it looks a little nicer. It's going to filter it, and it's going to unnest the emojis so that it creates kind of like a unique list of them. And then from that list, it's going to take the top 10 by count, so we can kind of see, okay, what were the top ones being used by this user. Okay, and then you can commit and do all of that. And then the last one is we're going to have a Wordle. So a Wordle is like a word cloud, and basically what it does is it takes the summary of all of the words being used and counts them up, and removes ones that are like obviously going to be used a lot, like the and. Those aren't very useful for informing decisions. So we're going to use this Wordle and do another header down at the bottom there. So we'll do that. Hashtag 4 times Wordle top terms used. And again, we're going to build with the R chunk. So 3 backticks, a curly bracket, R, and then I can call it something like Wordle or word cloud. echo equals false, and some new lines, and close my chunk. Okay, and then within this Wordle, again, it's going to be a render plot. This one's going to be a little different. It's going to be called, what we're going to do is take the user timeline, and it's going to go through, remove any extraneous symbols and text. It's going to remove punctuation, and it looks like numbers as well. So this is a string remove all. This is a really advanced technique if you work in string detection, which is basically like how computers can take text and strip the information from them. These are all commands around that. R has a great set of packages for these, and it uses a lot of regular expressions and things like that as well. Beyond the scope of this course, though. Okay, so rather than explaining all of this, basically what it does is it pulls user timeline, turns them into words, which it calls tokens, and then removes any what we call stop words. And as you remove the stop words and you remove any like single letter words, you can also remove numbers. And then pretty much what we are left with is just the words that are most relevant. And then that's what we're going to count. And then once we count all of those, we're going to create the word cloud using this random order. So again, for the sake of time, I'm just going to go copy all of this. I know you'll probably think I'm cheating, but that's okay. We are on a deadline. Okay, environment character. Okay, so something went wrong here. Let's see. Invalid evals. Oh, I know what went wrong. I forgot to add the render plot. So this should be render plot, and then quote. Okay, so let's see if that works. So again, it's probably going to give me an error because of the emojis not showing up. But if you can get them to show up, it's a really fun thing to do. Okay, and now I have a Wordle. And what's great about that is that Wordle will also change depending on, again, which source I use. So if I wanted to see what the iPhone user was using, or what kind of words they preferred, so there's just the iPhone. There's only a few tweets here. But as you can see, they're talking about other things. So really simple mechanics, but as you can see, it quickly builds up. And now we went from, basically like one data set, two data sets, to now we have two panels. In the first panel, we have an input, a graph, and a data table. In the second one, we have an input, a graph, and a data table, and an error, and a Wordle. So now you can start to build and build and build. We can create more windows if we wanted to separate these things out. The hard part isn't so much adding more things. Oftentimes it's trying to figure out what's left that we want to keep and is most meaningful for the user. So don't forget to save and write your commits. And good job. Go ahead and push your changes to GitHub. And once you've pushed those changes, what you want to do is make sure that these I've updated, and you can look on your main branch and see if there's more commits. There should probably be like, I don't know, maybe 12 commits by the time you're done, plus or minus 5. And then go ahead and copy this URL. You can either copy this one or this one. and submit that for the assignment on Twitter. So once you're here, you can say start assignment, and then just paste that URL, and that signifies that you're done, you're ready for me to look at, and I can click on it and make sure that all those files have changed. But yeah, that should be what it looks like. So there isn't going to be like an R markdown. Remember how when you knit it before, it created HTML, and then you could open up that HTML and send that HTML to somebody? This isn't going to work like that, because what you're doing is you're building a server, and that server is going to run the code and update in real time. So it's not stable, it's dynamic, it's reactive. And that's the whole point of an interactive data visualization, is that it depends on the user interaction to make the plots. So that's why you're not going to see extra files being made here. But if I take that whole GitHub and I put it on my computer, I should be able to run it and do the same things that you can do on your device. And like I said, this you can skip the emote part if that's not working for you. But congratulations, so you made your first interactive dashboard. You used data that was scraped from the web through Twitter, and you've created a way that a user could interact and find information that they were searching for. So good job.